With these very basics about numbers and operators out of the way, you're probably wondering how we'll use that in the blockchain. Well, we'll use that data to store it as data in our blockchain, so as the amount of coins we're sending with a transaction, for example. But before we do that, there are two important things I want you to understand about numbers because you might encounter it and then it might look strange. One is you can also write longer numbers in an exponential notation like 1e10. That is a valid number which Python will read and store as this number. So this here would be 1 million, for example. And as you can see, it automatically stores it as a float. And the even more important part is if you do some subtraction like 1 minus 0.9, what would you expect as a result? Well, you clearly would expect 0.1, right? But if you hit enter, you actually get a value close to 0.1. Now, this clearly is not the value we expected. We expected 0.1 as a result. Now, the reason for this strange-looking result is that, as you might know, computers work with zeros and ones. They work in the binary system. Therefore, any floating point number is a challenge for them. And that's not just the case for Python, but for any programming language. The reason for this being a challenge is that anything which is a decimal place, no matter if it's 100.1 or 0.1, is lower than 1. So the part after the dot always is lower than 1, per definition. Now, values lower than 1 are difficult because they only know 0 and 1. So values lower than 1 have to be reflected as a fraction of 1. And when doing these fractions, they run into problems if you're working with values which are hard to divide by 2. So if it's not a binary fraction, and 0.9 isn't, then you'll have a problem. For that reason, 1 minus 0.5 actually leads to a clean result because 0.5 can be written by the computer or understood by the computer as 1 divided by 2. Now, 0.9 cannot be written like this because there is no integer by which we can divide 1 which will lead to 0.9. Hence, it will actually chain a couple of divisions, and that would really be too complex here, which leads to the computer getting closer to 0.9, but it never fully reaches it, and therefore 1 minus 0.9 actually leads to this strange output. And therefore, even if you type 1 minus 0.9 minus 0.1, you get a value very close to 0, but not exactly 0. So this is a limitation or a certain missing precision you have to be aware of. It's not really an issue in your day-to-day life because these approximations actually give you a very close approximation, but it is something to be aware of. And most of all, I don't want you to wonder if somewhere in the course you see a value like this. It's coming from that missing floating point precision which is inherent to computers and also therefore to Python. It's not an issue of Python though. It's something the computer basically, well, has its issues with.